Hello and welcome to Algebra 1 with Miss Betsy. Today we are going to be continuing our discussion of how to factor trinomials. We're adding a little bit of an extra twist here, and we will be factoring trinomials that have the form ax squared plus bxy plus cy squared. And that really sounds like a mouthful of letters, but it's not that big of a deal. It's not that big of a step from what we learned about in our last video. Before we get started though, can you tell me why the belt was arrested? Because he'd been holding up the pants. So let's go ahead and work with this. We are in Section 9.6, which is Chapter 9 of my text, Algebra 1 for Christian Schools. It's published by Bob Jones University Press. I'm using the second edition. If you wish to follow along with me, I am on page 384. And what we notice here about this trinomial that's a little bit different, the only additional twist that we have is that we have variables in all three terms. What we had been doing factoring before, it was just something that would look like 3x squared plus, can't make up one off the top of my head. Can't believe that. Let me pull back and pull an easy one for you. 3x squared plus 5x plus 2. One of the rare times I was stumped with pulling out a trinomial. Ax squared plus bx plus c. This is the only difference. Now, instead of it just being one variable, we've added a second variable, 3x squared plus 5xy plus 2y squared. So we just simply have to include the factorization of the second variable. Other than that, it's just pretty much exactly what we were doing in our video for section 9.5. So let's go ahead and do one of these. This example from our book is factor 2x squared 3xy minus 14y squared. 2x squared minus 3xy minus 14y squared. And I'm going to take the time to make sure I've copied this correctly. 2x squared minus 3xy minus 14y squared. And I have that factored correctly. What do we notice about the signs here? We have to have a negative product. The only way you can have a product of a negative 14 is by having a positive and negative factor. How are we going to factor our first term? Well, you can only factor 2 one way. So we know that we're going to have a 2x and an x. We know that one of these signs is going to be positive. We know that one of these signs is going to be negative. Now, what's the next thing that we do? We have to factor our negative 14. What possible combination of factors do we have? Positive 1, negative 14, negative 1, positive 14, negative 2, positive 7, positive 2, negative 7. Those are the ways in which you can have negative 14 factored. What did I not include in here? I did not include the factorization of y. So what does that mean we have to make sure we have in here? This is going to be y, 1y, 1 times y, which is y, times the negative 14y, where we have a negative 1 times y, which gives us a negative y times 14y. We have negative 2y times 7y. We have a positive 2y times a negative 7y. Do you actually have to go in and write these y's as you're factoring them? No, and you saw exactly what I reverted to, even though I wanted to illustrate to you the factorization of y squared, because you know automatically that y times y is y squared. So now we're going to have to figure out how we can arrange these factors in here so that when we add together our outer partial product and our inner product, we end up with this central term here. So what are we going to do? We can say, what happens if we put in the plus y and the minus 14? Is this going to work? Do some of this stuff by head. Outer product, negative 28 xy. It's not real likely that this is going to be the one that we need, is it? And it's not. Plus xy. Does us no good, that's a negative 27 xy. What can we do now? We can change the order. We can say 2x minus 14y x plus y. What do we have for our inner and outer partial products? Well, the outer, 2x times y, 2xy, the inner, minus 14xy. Does that work? Nope. So here we have no, here we have no. So what has that taught us? That the pairings of 1 and 14 don't work. What are we going to try next? Well, let's just go ahead and do negative 2y and 7y. 2x minus 2y times x plus 7y. Now I know immediately that this is not the correct answer. This refers back to what I said in the prior video. We have no common monomial factor. But when I arrange the terms in this order, what do I have right here in this first binomial factor? I have a common factor of 2. So if we have no common factor in our trinomial, there's not going to be a common factor in our binomial factors either. But I'll illustrate it for, I'll verify that. Our outer product, 2x times 7y, 14xy minus 2y times x minus 2xy. Doesn't work. So this one doesn't work. So long about now you're thinking this one here had better be working. Let's see what we get. We have 2 minus 7y let's try the 2y minus 7y. 2x plus, let's do the 2x plus 7y times x minus 2x brain freeze here. Positive 7y minus 2y. Minus 2y. Is that one going to work now? Our outer product, 2x times a negative 2y is negative 4y, xy, plus 7xy. Or closer, but we've got a positive 3xy instead of a negative 3xy. So what's wrong? Because I said surely it needs to try. Well, all we did here was we tried this third pair of factors. Two different orders, it's still not working. So, what are we going to do now? We're going to try this last pair of factors, and I'm out of room on my paper, on my board. So you can see that these problems can take a very long time to do. A lot of paper to do. What are we going to try now? 2x, x. And I said we knew that we're not going to have common factors in our binomial. So it's not going to be 2x plus 2y. It has to be 2x minus 7y, x plus 2y. This is my last option. It needs to work. Our outer product is 2x times 2y is 4xy. Our inner product, negative 7y times x, negative 7xy, which gives us a sum of negative 3xy. This finally was the solution that we were looking for. Here I have outside, inside, my first terms multiplied together, 2x plus. Our last ones, minus 14y squared. You combine the center-like terms to get 2x squared minus 7xy minus 14y squared. So what I just did was I checked for you and verified that the product of these two binomial factors is indeed the trinomial that we started with. Now, if you've noticed, I'm being very precise and specific to use all of that vocabulary when I go through the review of this so that you understand what we're doing. And you also saw in this one that we went through a bunch of different combinations. What you're going to learn is very rarely or less frequently are you going to have a big difference in the size of the factor, like a 1 and a negative 14. It's usually going to be factors that are closer together, and I promise you the more that you practice these, the more quickly you will be able to solve them. Now, what in the world did I do with my eraser? Let me do one more example for you, and then spend a bunch of time on your homework practicing these. Example 2 is 18a squared minus 57ab plus 35b squared. Then you've written it down, you verify that you have copied it correctly. 18a squared minus 57ab plus 35b squared. And you look at this and you go, big numbers. Don't start factoring 18 and 35. 1 times 18, 2 times 9, 3 times 6, 5 times 7. Usually when you have big numbers like this, matter of fact, always pretty much like when you have big numbers like this in Algebra 1, you have a common factor. Okay? What are factors of 35? Well, factors of 35 are 5 and 7. How ugly! 18 does not have a common factor of 5, cannot be factored by 5 or 7. So what is this telling you? That you have a bunch of options. I just said, don't immediately start trying to factor, look for a common factor. It's exactly what you need to do. Usually when you have larger numbers like this, it's what's going to happen. Sometimes you're going to go, seriously? Seriously. It's just a little bit of multiplication. Just allow yourself the time to do this. Remember, if you're allowing yourself 45 minutes to learn a lesson and to do the homework, it's not going to cut it. Algebra takes more time than that. Let's look at the signs. What do we know? We have a negative sign in the middle. We have a positive third term. What's the only way that you can end up with a positive product? If both of the signs are the same. Positive times positive, negative times negative. What do we know we're going to have here? We know that these factors here are going to have to be negative because our center term is negative. Okay? So let's go ahead and see what we can do. Negative times negative. We have that little piece of information that we know. How can we factor this first term? Well, 18 can be either 1 times 18, 2 times 9, 3 times 6. I'm going to take a glance here and see what it ends up being. And I'm going to track with it. I'm looking at this, and when I'm looking at large number combinations, with my practice, I'm thinking it's most likely going to be the 3 and the 6. Just it seems that that's the types of problems that they give us. So I'm just going to go ahead and arbitrarily begin with my first terms being 6x and 3x. Could you have started with 18x and x, or 9x and 2x? Sure. You pick whichever one of these pairings you want to. In my experience, these come up with the answer most frequently. Now, how can I factor 35? Well, at least 35 is easy. There's only one way that you factor 35. 35 factors into 5 times 7. Because we have to have a positive product but a negative sum, both of these factors have to be negative. So we can either put 6x minus 7, 3x minus 5, or we can say 6x minus 5, 3x minus 7. How are we going to know? What do we do next? Well, we take our outer product, positive 6 times negative 5, negative 30x, negative 7 times 3x, negative 21x is equal to a negative 51. Oh, how funny. It's not x. We have, this is going to be 6a and 3a. For those of you who are watching this who are not in my class, I apologize. For those of you who are in my class, I'm just going to go back and put the correct variables in. Does not change the truth of this example as I'm working it out. I just had my variables wrong. Negative 30 AB minus 21 AB, negative 51 AB. We're trying to get a negative 57 AB. This one doesn't work, does it? Nope. What happens with this arrangement of factors? 6A minus 5B, 3A minus 7B. You get so accustomed to using x as the variable for anything, if you slip too much into an automatic mode, you end up putting x's where they don't belong. 6a times 3a, 18a squared. 6x times a negative 7b. 6a times a negative 7b, negative 42ab. Negative 5b times 3a, negative 12ab, negative 5b, negative 7b, plus 35b squared. What do I end up with when I have the sum of these two, of the outer and the inner products? I have 18a squared minus 52, 42, 52. I've got a negative 54. Did something wrong, didn't I? What did I do wrong? Well, the 6 times 7 is a negative 42. The negative 5 times 3 is a negative 15. Who knows why I wrote a negative 12? Negative 15. Now we have a sum, negative 57 AB plus 35 B squared. This is the trinomial that we're looking for. Therefore, the solution to this problem is the product of the two binomial factors, 6a minus 5b times 3a minus 7b. Take some trial and error. Be careful with your variables. The only way that this is different from what we did in section 9.5 is, remember, when you're factoring this last term, you're going to have an extra variable in there. If I had said, taken the time to say 35 b squared, 35 b squared, 5b times 7b, I would have been much less likely to slip into that little error where I was using x's. But there's nothing wrong with the factoring process. I'm deliberately leaving this video as it is so that you see that you too can go through and get your variables inadvertently wrong, and it means nothing. You're still doing your factoring. But be very, very careful to be aware of what variables you're using. Work with these, play with them, send me a text if you have difficulty, and I'll see you next time.